Good evening. So let's start the session. Welcome to the week 8 of the live interactive session of the fabrication techniques for MEMS-based sensors, a clinical perspective. The course is being taken by uh, Professor Hardik Jitendra Pandey of IISc Bangalore, and I am the PMR of Teaching Assistant Vikas Pandey from IIT Jodhpur. This is a brief about me. You can check my portfolio page for more details. That's the Meet link we use to join every Tuesday. And all the recording of these classes are also available on the YouTube channel mentioned here. You can even write to me to my email in case you have any query. So before going forward to questions, if you have any doubts or anything to ask about things taught in the class, you are welcome to ask. Yes, any doubts, any questions? Okay, so let's assume there are no questions. So let's come to problem 1. What is the purpose of the heater in drug screening device? An elevated temperature At elevated temperature, sensitivity increases. To maintain normal human body temperature on the chip, material is stable only at elevated temperature or all of this. Yes, any answers for this?
So B, to maintain the normal human body temperature on the chip.
Very right. So it is to maintain the normal human body temperature. So coming to the next question, in vivo situation of our body can be mimicked most faithfully by microfluidic chip, ID structure, microtubulettes with the peristaltic pump, or all of these individually can mimic. Is any answers to this?
So microfluidic chips, it's A, or
Hmm.
C, it's
A or C. There is a
microtubules and
there is a confusion between these two. Okay.
C.
Any other answers? I think Dr. Virendra, would you like to answer this? You are not audible. We cannot hear you. Maybe some problem from his end. Okay. So in general, like if we see the microfluidic chip or microtubulates with peristaltic pump, they both have uh, some similar kind of structure in the sense they have chip and tubes connected. But microfluidic chip has one additional advantage that the like here the, here only the content can reach till the sensor. Like if there is a sensor here, till there this fluid can be put, and it will be in macro level, like it will be bigger. Whereas in case of microfluidic chip, we can go even below the sensor, up the sensor, wherever we want, because there are tubes built inside the chip. Okay, and we can control them using some control unit, like how much blood, how much serum, how much which type of fluid has to go. And in this way, we can mimic the system more accurately using microfluidic chip. These are, you can say, some older techniques. And in fact, microfluidic chip is a like advancement of this only. So a better way to do this is using microfluidic chip, where we can uh, put things in precise amount like with mic micromolar or not mole microliters and uh, such kind of quantities, micro and nanoliters of fluids flow in this, and we can have a very precise control as well as we can maintain things very easily there. Whereas in case of using peristaltic pump, there we have bigger tubes, and that's why we have to deal with a larger amount of fluid, and to control this and to have precise control over this is difficult. So the correct answer is microfluidic chip. Fine. Any doubts in this?
No, sir.
Okay. The next is a microheater is fabricated on silicon wafer, followed by deposition of insulation layer. This is the general thing we have been doing again and again. So a microheater is being fabricated over a silicon wafer. On it, we are first depositing an insulating layer, that is SiO2 in this case. So a microheater has to be made here. Okay. A metal is deposited. A metal layer is deposited, um, followed by. So on this also, SiO2 is there. On this also, insulator is put, so SiO2, and then on it, IDE patterns has to be made. Okay. The fabrication process of this device is a how many mask process? One, two, or three?
2 months process.
Two mask process. So where will we be using the mask?
One at the time of heater, and the another one is for ID structure.
IDE structure. Okay. So there are two masks. Okay. So, so uh, let if we see the top view, let's see from the top. Okay. So first, let's say we have a structure and we are covering it with, say, nichrome. Okay. And then we want to pattern it to make our micro heater. So to pattern this, one mask is used. Fine.
Yes.
And so let's say this is the micro heater we made. Okay. Then above this, we are putting silicon nitrate, not silicon nitrate, sorry, SiO2. Okay. Silicon nitrate also is used in many places. Okay. SiO2, let's see where. So this SiO2 deposition will actually cover everything here.
So for contacts, we should use
Yeah,
another mask.
yeah. For contacts, actually, we'll have to use another mask. Like for this, above this, we will again put metal at full metals on the top of it. But before this, there is one thing that we need to open up this the areas where we need to make the contacts for next level. Okay, like these pads. So this SiO2 will also have to be patterned. Like once the SiO2 is deposited, we will have to open these areas. Okay, and then we will do a thorough metal deposition that will be made for IDE. And in fact, in the IDE pattern mask only, these contacts will be formed. Okay, this contacts of this micro heater in this will be formed in the ID pattern itself, the mask of the ID pattern. Because if SiO2 is kept like that, we will not have the contact going till the micro heater. So in fact, contacts is not a different mask. The different mask, another mask is of patterning of SiO2. Fine. Are you getting it?
Is
Yes,
it
sir.
a 3 mask process then?
Screen mask, I didn't get.
Hmm.
We are talking about photolithography mask only.
Okay, okay.
Even if we go for shadow mask or screen mask, uh, in that also depositing SiO2 using shadow mask is a difficult process.
Okay, okay.
Yeah, so we are talking about photolithography only. So one mask is for patterning this nichrome, or we can say the heater, micro heater. Second mask is to pattern SiO2 for the contact areas and wherever we want it to be open. And the third mask is for ID patterning, ID plus contact pads, we can say. Fine. So how many masks in total?
That I was saying, na, it's a three mask process.
Yes,
It's,
it is a three mask process.
yeah, yeah.
Yes, sir.
Yeah.
3 months process.
Yeah. Actually, Dr. Virendra, your voice is not clear.
Okay, sir. Okay, okay.
Yeah, now it is clear. Like earlier, it was not coming clear.
Okay, sir.
That is
Okay.
why we were not able to. Yeah.
Yeah, we have used the same three mask process at Semiconductor Laboratory Mohali, SL Mohali.
Okay. Oh, you are from SL Mohali?
No, sir. On that time, I was DRDO fellowship.
Oh, great. Great.
Right now, I'm in teaching field.
Okay, great. So
Okay, sir.
certainly we will get to learn something from you also.
No, no,
Yeah.
it's not. We
Okay.
came to IIC Bangalore also from TBRL Chandigarh, but they refused to fabricate that G switch.
Okay. Yeah, they have some
In
standard
fact, one
protocols,
of
I
my
think.
publication is reviewed by IIC. But Nagar, sir, I forgot the name. That head of the department.
Yeah. Actually, I am from IIT Jodhpur. The
Okay, okay,
faculty who is teaching this course, he is from
okay, okay,
IISc.
okay, okay,
I
sir.
am from IIT
I
Jodhpur.
Yeah, we visited that facility. It's sponsored by DRD only, na, CENE.
Yeah. Yeah, Sense
Yeah,
Laboratory. Yeah.
right, sir, right, sir. I'm listening, sir. Tell us.
Yeah, sure. So generally speaking, like when we see it at first, it looks like it is a two mask process, and we forget the area where we have to open the SiO2. So it is in total a three mask process. Clear? Arvindji, is it clear now?
Yes, sir. Yes.
Yeah. Okay. That is why this mask number of mask I am asking every week. I think some question related to this.
So last class also we it's a 3 month process, something
Yeah.
like SIO.
There we were discussing about shadow mask, like how we are using the shadow mask. Yeah.
Yes.
Okay. So let's go to the next process. The static platform to determine efficacy of drugs gives result different than the dynamic system. The reason behind it is drug cannot be properly placed on the tissue in the static system. Drug human body is a dynamic system, so it can be replicated properly using static system. Human body acts as static system, so the statement is false. Human body may be a dynamic system, but static replication gives the same result as dynamic system. So which of these is true? Correct. Yes. Any answers?
B, I think. I don't know.
Yes. No
Because
worries.
dynamic system is there. Human body is dynamic system. It's
Yes.
very difficult to mimic human body.
Yes. And in fact, dynamic also we cannot mimic it perfectly, but we can
Yeah,
go
yeah.
very near the real system. So in that sense, dynamic systems are better preferred. So this is the correct answer. Okay. So let's go to the next question. With regards to microfluidic check for rapid drug screening, now we have come to the questions related to lecture one. For rapid drug screening that was discussed, evaluate whether the following statement is true or false. The normalized impedance of the drug susceptible cancer cell increases upon addition of the drug. Is it true or false?
False, sir.
False. So, false. Why?
Upon addition of the drug, more cancer cells will be uh, dead or reduces. The
Mhm.
conductivity will be increases,
Conductive will
and
increase
impedance will be
less.
decreases.
But why this conductivity changes there? Like, what is the factor that plays the role? Is there any increase of charge, decrease of charge, or what is happening here? Any idea?
No, no, sir.
Okay. Like impedance will decrease. That is
Yes,
uh, for sure. Okay. But why is it decreasing? Decreasing means when impedance is decreasing, the conductivity will increase or decrease?
yes, increase.
Increase. So conductivity decrease when this is increasing, right? So what can be the factor for increase? Sorry, when yes, when the conduct impedance is increasing, the conductivity will decrease. Okay, but here we are saying that no, it will increase, right? Conductivity should increase because the impedance should decrease. So what can be the reason for increase of conductivity?
Cancer cells having less conductive, or maybe
Cancer cells are less conductive. That is right. Okay, like you will have to dig upon it a bit. Okay, it is something related to charge. Okay, charge hold by that cell when it is dead and when it is alive. Okay, it will have difference. That not cell or tissue we can say. The dead cells will have different charge holding capacity, as well as alive cells have different charge holding capacity. Okay, so you will have to dig upon a bit, and if you are not able to find, tell me. I will tell in the next class. Okay.
oh,
So let's consider the following statement related to microfluidic chip for rapid drug screening that was discussed. The substrate used was silicon wafer. The electrical sensor were pattern like ID pattern were direct patterned directly on top of nicrom microheater, both or neither.
D, sir, neither.
Neither. So what is the correct wafer? Which wafer was used there?
In the class, they used optical sheet on the top IDE, on the bottom it was heater.
Yes. And there was like there is a separation, right?
Yes, sir, yes, sir.
Okay. It will not be put on the top of micrometer. So neither of these is correct. There is a transparent optical sheet we can say, uh, or like glass. Okay. This side we have it was a glass wafer. This side, if we are patterning the ID pattern, this side microheater. Okay.
Yes, yes.
And what is the use of this microheater?
To maintain the human temperature.
Human temperature. Like that is the first question we answer. Okay. So
Yes,
the if the fluid comes like suddenly like we are seeing the other side, like a tube like structure is there. Certainly such a tube cannot be made easily. Okay. So like let's suppose such a tube is there. So it will heat as well as this ID pattern will be able to sense it. Okay. Okay. For the fabrication of SU8 pillars, which one is the standard process flow? Photoresist coating, soft bake at 370 363 Kelvin, UV exposure, development, hard bake 393 Kelvin. So what is the value of this in degree Celsius? Yes, any idea?
Minus 273.
Yeah, minus 273. So it will be almost 90, right? 90 degree, and then this will be 120 degree.
So this question
Okay,
is given in a wrong form in the assignments. The question
okay,
was different, but the answers are same. But the question may be repeated. The
okay,
previous question will be the same question will be asked for the second time, but the answers was different.
okay,
Please check once. Sir.
okay. For that, you will have to just post in the discussion forum is there.
Yes.
Just post it there once. The TA related to like the assignment and this, like they are seeing like there is a different TA for those. You will have
I
to
think that
like just yeah,
soft
yes, yes.
soft bake at 65 degree, I think, if I'm not wrong.
Soft baking is at 65 degree,
65,
right?
65 degree.
Yeah, and hard bake is at
Hard bake,
90,
I don't remember right now, sir. Hard bake,
90 degrees.
but soft bake maybe
yeah.
130 or soft bake is different. It's a negative photoresist. In case of soft bake,
Mm,
it is different. If I'm not wrong,
yeah. Yeah, this is SU8 is a negative resist, right?
negative photoresist.
Yeah, negative photoresist. Okay. And since it is a negative photoresist, the process will be a bit different than the normal photoresist.
Yeah,
Like,
one is like exception.
yeah, one exception. So, what is
Dr.
that?
Hardik Pandey discussed this.
Yeah. So, what is that exception that we have to find out in this?
First, we have to do the hard bake, then go for development.
Yeah. So, we have to first do the hard bake and then we have to go for the development. Unlike the normal process in which we have development and then hard bake, development, hard bake. So, certainly these two are wrong for sure. Okay. Now we have these two options left. So let's find which one is correct. So it is saying 338 Kelvin soft bake and hard bake at 368 Kelvin.
Just 68, and then development.
Yeah. So and this one is 363 and 393. So which one is the correct one?
C, sir.
C. Okay. So because it is 65 degrees Celsius, so C is correct. So what is the correct value for this hard bake then?
95 degrees.
95. Okay. And this is not something that we when we are doing this using the photoresist actually what happens that uh, we are generally working with one photoresist like some standard photoresist and we remember the values for those. Actually it mostly depends on the resist we are using, like even for uh, positive photoresist, if we have a different photoresist that can have a different soft bake and hard bake temperature as well as time. Okay, so this is particularly for SU8. So for SU8, it is 65 degrees Celsius and 95 degrees Celsius. Okay, so should we move to the next question?
Yes, sir.
In the fabrication of microfluidic devices, PDMS can be used. Okay, PDMS, which is a soft material, we can say soft and a bit flexible material, belongs to a group of materials commonly referred to as silicons. Generally, PDMS is patterned by which of the following techniques? Optical lithography, E-beam lithography, soft lithography, or we can use all of this.
Soft lithography.
Soft lithography. So, what is the difference between this soft lithography and not like optical or e-beam lithography?
For hard metals, we should use the above tool. Right? In the
So
class, Sir also told it will deposited by using soft lithography in the
yeah,
class.
the answer is correct. But now is like, how is it different from a normal lithography process? Is it different, or is it just that we are using some other kind of light source for it, or what is the difference?
No,
Okay.
not
Okay.
this.
So let's see. First, let's see what is the difference between a optical lithography, that is the normal lithography, or we say photolithography, okay, and e-beam lithography, okay. And why is this actually like, why is e-beam preferred and when is optical lithography preferred? Okay. So in
Is
case
it
of e,
is it
yes,
kind of molding, sir?
yes, it is like soft lithography is kind of molding.
Okay.
Okay.
Once upon a time, we have used this PDMS layer to protect, to make that sensor biodegradable.
Yes, it is mostly being used in flexible sensors
But
also.
yeah, but we simply pour in and then taken what you degassing and then prepared the layer.
Yeah. Yes, yes.
Okay, sir. Soft
Okay.
lithography.
Yeah. Soft lithography is the correct answer. But let's see how is it different, a bit different. Okay. So first thing we have to understand like the difference between photolithography and e-beam lithography. Just the difference is of the source. Instead of light, here we are using electron beam as the source to expose. And since it is electron beam, we cannot go for complete exposure at once. Like here, instead of mask, software patterns are used. Like it is fed in software and then it will raster line by line, like where it has to hit, where it don't have to hit, and such kind. Very similar to laser lithography is also there. So, but the major difference comes here is that the source of a normal lithography is approximately 365 nanometer is the source, whereas e-beam can go to source of 2 nanometer. So when we are going to smaller wavelength, so certainly our minimum feature size will be like it. We can go for very lower dimensions. So okay, it should be micrometer here. Okay, so in case of photolithography, we can go to half micrometer maximum, so that is around 500 nanometer. Whereas in case of e-beam lithography, we can go up to 6 nanometer dimensions. This is one advancement. Other is the alignment accuracy is a bit more than 1 micrometer in case of photolithography, whereas in case of e-beam lithography, since the microscope there also changes to e-beam microscope or FESEM, SEM kind of thing. Okay. In fact, the same structure is used for both. Okay. So it is around 6 nanometer. But the problem is, the difference is that in case of photolithography, we can do it at a very fast rate, like the whole thing will be exposed at once using a physical mask. Whereas in case of e-beam lithography, it is slow because the electron beam will have to move throughout the wafer slowly, line by line, exposing small area at a time. Fine. Now is the next thing is that okay. Now we have lithography. So now suppose we want to go for soft lithography. So the first process in this case will also be, in this case also, the process will start with photolithography or e-beam lithography according to the dimension we want. So we have the pattern and we are not going to bond any glass or anything over it. But instead of that, a PDMS, PDMS is poured over it and then it is peeled out. And in this PDMS, we will have embossed structures. Okay, that is the soft lithography. It is cured and it settles and then it is peeled off. Is it right? This, Dr. Virend, is it the way you did for PDMS?
Yes, sir. Yes, sir.
So
Yeah.
pouring,
Thank you.
curing, and then peel off. So it also involves photolithography and e-beam lithography. But the thing is that since it is a flexible material, like as well as we cannot, since it itself is a resin and above it we cannot pour photoresist, right? So uh, to avoid this problem that the resist itself we can, like it is not photosensitive, as well as it is something that will like that will stick to the photoresist and we cannot do anything with it. Okay, so to take care of this, a inverse process is used, and this is specially known as soft lithography. So that also involves photolithography, and then comes the soft lithography process, that is stamping or patterning. Some people even call it as stamping or patterning, like similar names are used. Right? So the correct answer is soft lithography. And if any such questions comes like optical lithography versus e-beam lithography, which is better? I think one question we discussed previously also, that UV UV was there and electron, like which source is better, UV, electron, deep UV, and X-ray, right? So which is better? So in all these cases, just remember that which will have the better resolution, the one with lower wavelength, better resolution. Because resolution, like it is defined by Rayleigh criteria, so it is approximately almost two times the wavelength of the source being used. Here also, if we see, like here, you see, it is 300 nanometer. So minimum feature size is generally 0.5 to 0.6 micrometer, almost two times. It is 2 nanometer, like it should be 4, 5, 6, like that is the range. Okay. So in general, like the resolution will be almost two times or more than, or like somewhat near two times the wavelength. So if any such questions comes like which one is better, e-beam, e-beam lithography is there, UV, deep UV lithography is there, X-ray lithography is there, like which one is better, you just put it in sequence, like which one will have the lowest wavelength, that will give us the best resolution. Fine. So in all of this, which one will be better? Any answers?
X-rays.
X-ray. Why not electron? Electron will be better than X-ray, I think.
I don't know wavelength for electron.
X-ray, the wavelength is in what range?
I'm not remember. So,
X-rays also have wavelength going in picometers actually sometimes. So certainly it will be better than electron beam and deep UV. But the problem is that uh, it is very costly. That is why we don't have X-ray lithography, and like till now we are not going to below nanometer levels in general. Like maybe when this pico materials will start coming, then we might have X-ray lithography and all. Okay. Okay, so let's come to the next question.
sir, in the which one is
Yeah.
better, sir? Electron or X-ray?
When we like some part of X-ray actually coincides with this electrons wavelength. So in that part, certainly they will perform similar, but X-rays go till 10 to the power minus 12, I think. So in total, we can say X-ray will be better.
Okay.
X-ray is better. Some part of electron and X-ray, like they are comparable, having comparable wavelength. In that case, both is fine. But since electron beam is cheaper than X-ray lithography, we go for electron beam lithography.
Okay.
Okay. In the microfluidic chip for rapid antibiotic susceptibility testing that you have seen in the lecture, the antibody was used for what purpose? To capture antibiotics, to capture bacteria, to ensure better bacterial growth during incubation after adding antibiotic drug, to enhance the killing of the bacteria by the drug. Which of the following?
B, I think, to capture the bacteria from the sample.
Bacteria from the sample. Certainly, like we don't want it to be taking part in killing or making it grow. Okay, and we want the bacteria to be fixed so that the drug can act over it. Okay, for that we are using the uh, sorry, we are using the uh, rapid acha, antibody. We are using
So
the
D,
antibody for, yes, yeah, what you are saying.
is that antibody is used to kill the bacteria, sir? Is that D is not
No,
correct?
no, because we want to check the susceptibility only of the drug. We don't want any other thing. Like if you think that, suppose we are trying to test something, like if we have only one parameter to check, that will be much easier, right? So certainly if any other factor, like apart from drug, if anything else is killing or helping in the growth of bacteria, that will be then a bit difficult for us. Okay, so in this case what it is done, it is just to hold it, or you can say to capture, so that it can easily act with the drug. And like if you remember this picture, I think sir also showed this in uh,
Yes, yes.
yeah, this is one of his papers. Like, so what it does is that from this whole fluid, it try to capture the bacteria. Okay, and then it incubates. Like at one point, it starts growing along with the antibiotics. Like bacteria and antibiotic both are kept, and then it starts. Okay, and then impedance measurement is done. Okay? So it is to capture the bacteria. It does not help in growth as well as does not kill. Though antibodies are generally meant to kill something, right? But here it is just to hold it, not like not killing or not helping it grow. Okay. The following statement related to experimental results that were discussed in antibiotic susceptibility testing microfluidic chip. Upon addition of the antibiotic drug to the microfluidic chip containing the captured bacteria, so the bacteria is fixed on the bacteria is fixed on the antibody. Okay, it is captured on this, and it is saying that the antibiotic drug, like drug that is designed to kill this bacteria, okay, or some other like what we are testing, is added to this fluid, the normalized impedance will decrease. Is it true or false?
I think false.
Why false? That is why.
Because this normalized impedance decreased. It doesn't sound good.
That that is something uh, like,
But
how will we
no,
explain?
because it's a mirror guess only.
Yeah.
I don't know.
Impedance decreases, or let's say, if it is not sounding good, so let's say impedance increases. Okay. So how will it increase or decrease? Yes. Any idea?
No, sir. Thinking.
Okay. Yeah, Arvindji, any clue from your side?
No, sir.
No? Okay. I think I have already given the answer in the one of the previous question when we were discussing something about impedance.
The bacteria having higher impedance than the normal cells.
Here, only bacteria is there, no other cell is there. Like there, cancer cell and like alive and dead cancer cells were there. Here, alive, you can say alive and less, like more and less bacteria are there, or alive and dead bacteria are there.
No, sir. I don't.
Okay, so what it is there, that the whole thing is a culture. Okay, culture means the bacteria is put there and bacteria will keep growing. Okay, so if we have, we are killing some bacteria. Okay, like suppose the drug is acting over it, and suppose there were like, suppose there are 10 bacteria at the beginning. Okay, and normally growing, say after 10 minutes they will become 1,000. Okay, now suppose, uh, like we are putting drugs in a different proportion. Okay, and a drug is at the beginning of this process itself, we are putting a drug and it is able to kill 4 out of this. Okay, so our starting point becomes 6 bacteria and they will keep multiplying. So at the end, will we get 1,000 bacteria after 10 minutes? We will not get, right? So we will have some less number of bacteria. Certainly, we will have to count how many multiplications can go and all. So based on this, like if this is plotted, and every live bacteria, okay, will have some charge with it. It carries some charge. Okay, so if we have like less number of bacteria, say, though it will not be 600. Okay, so let's say 600 bacteria are there, because now the starting point instead of 10 bacteria was 6, since our drug killed 4. Okay, so now we have 6. So compared to 1,000, we, uh, we will have lower or higher charge. Yes, any answers? Am I audible to you?
Audible, sir.
Hello?
Audible.
Yeah. So, like earlier, after 10 minutes, like without any drug, it was 1,000 bacteria. Okay. Now, after introduction of drug, I am taking example. I am not taking the correct numbers. Okay. So now we have 600 only. So the charge is more or less in this case. Yes. Any answers?
No, sir.
Like charge is less or more? Like let me put it again. Okay. So let's say we have this a culture of bacteria in which we started with say 10 bacteria at beginning. Okay. Then after 10 minutes, this culture will grow to like size will remain same, but it will have now 1,000 bacteria. That is the normal process. Now the next is say we are putting 10 bacteria plus a drug, and this drug is meant to kill some bacteria. Okay, and then we have say after same 10 minutes, ideally if all the bacteria were alive, we will get 1,000 bacteria. Now we are getting 600 bacteria only. Okay, but we cannot count 600 bacteria. Okay, so what is the method to know is that we know that each bacteria have some charge associated with them, and if there is a charge, there will be flow of current. Fine. Is it clear till here?
Yes, sir. Yes, yes.
Okay. So now the next thing is that when yeah. So if we find that there are 600 bacteria only, how will we find that there are 600 bacteria only? By measuring the charge. But it is easier to measure the resistance or impedance compared to charge. Okay. If there is less charge, so will there be more current or less current? Less charge means less current or more current?
Technically, less charge means less current, but here I think it's not.
No, this fine. Less charge means less current,
Mhm.
right? And when there is less current, that means it is having more impedance,
Mhm.
right? Less current, that means more impedance.
More impedance. So impedance will increase.
Yes, impedance will increase. Why?
Is there
Because
is there any relationship with frequency?
uh, because here we are mostly dealing with DC and all. Like I think frequency will not
Okay,
have
okay, sir.
effect.
Okay, sir.
Yeah, like not exactly DC, but yes, the impedance will like once we have plotted. Like suppose we are doing the whole experiment at one fixed frequency, you can
Mhm.
say. If we change the frequency, certainly like for every
Okay,
one,
sir.
like we will get a different graph. So let's compare it with one frequency only. Okay.
So for
So
one particular frequency, this
yeah,
normalized impedance will increase.
increase because for on that frequency, like if there was an impedance earlier, now the impedance will certainly be more. Why more? Because we have less current flow now.
Less current.
Yes. Is it
Okay, sir.
clear, Arvindji?
Uh-huh.
Yes, sir. Yes, sir.
Now clear, right? So, like the answer was correct that time also, not an issue. But we have to understand so that if the answer question is in some way around, like we are able to answer that also. Okay. So, like if we see this at the beginning, like you see at the beginning, we cannot like there is some change in proportion, like this. this line, if you see this graph, this from Sir's paper only, okay, like this is the impedance when nothing is kept, okay, only the E. coli bacteria, and in this case, like MRSA is put there, okay, and then with drug, like some amount of drug takes time to kill the bacteria, some takes less time, some can be very fast. Fine. So in this case, at the beginning, like we can have some different proportion. In this case, it is working very fast. We can say this is a bit slow and this is the slowest drug. But yet all of them are acting. And then after say 30 minutes, if you observe for all of them, you see this is what should have been the correct impedance if the cells were perfectly alive, like they were growing normally. But what happens is that we find that the impedance is more. That means we have less number of the cells or the bacteria that were expected. That means these drugs are working fine. Like, and this you can find like which drug in what proportion will give the best result. And sometimes it happens that here, if you see it properly, some drug might not be working at first, and then it might have worked very well after some time. Okay, so we can find out the susceptibility using all these methods. Okay, so and in all these cases, you see after a line is made, so that we study after 30 minutes, like for a better comparison. Like after 30 minutes, we see this is the culture time, minimum culture time given for this. Fine. Similarly for this also, this is the base line that we have, and then these are the other ones are with different drug added to the culture at the beginning. Fine. Any confusion in this?
No, sir. Thank you.
Okay. So the answer is false for sure. Okay. Now let's come to another question. We can measure the impedance of any tissue by placing it on interdigitated electrode. So we have this ID pattern, and if we put the tissue over it, some tissue over it, we are putting the tissue over it, we can measure the impedance. We now apply a drug to this tissue. Okay, so we are now adding, sorry, we are now adding some drug to it, and that drug is supposed to kill this tissue. Okay, if the drug is effective in killing the tissue, the impedance will increase, decrease, remain the same, none of the above. Yes. Will it increase, decrease, or remain the same? Yes. Any answers? It is very similar to the previous question. If the tissue is alive, it will have a charge, and if it is dead, it will not be carrying that charge. Okay, so the impedance should increase or decrease.
Decrease.
Okay, so okay, sorry. Okay, so it the impedance should, it is about killing the tissue. Okay, sorry, it is about tissue, not a bacteria. Okay, so I think this one should go to the previous question like this. Okay, so when we have less number of tissue, the impedance should decrease, not increase. But why? Here it is also about charge. Okay, but remember, in the case of cancer cells, okay, in case of cancer cells also, the dead cell have more charge, like is having less impedance. Okay, why less impedance? And like that charge thing is for this bacteria, right? That is a moving bacteria, and since it is held by a antibody, it will have a potential in the charge. But in case of tissue or cell, if it is dead, so why its impedance is less? Any idea on this? Yes. Any answers for this? I am audible, right?
Yes, sir. Sorry.
So, anything that comes to your mind? It is related to charge only. Okay. So, think about the answer.
The water molecules in the tissue produces some kind of conductivity. Once
Yes.
the tissue was dead or killed, the impedance may change.
Yes, the impedance will decrease because now that thing will not be there. That insulating part is removed in a sense, you can say, right? Like, see the lecture, you will find the answer to this. Okay. The answer is certainly it will decrease. And this one should go to the previous question. Like, this is about the bacteria thing. Okay. A very similar thing happens in this case also, but just the opposite. You will have to find out. Okay. So, what is the soft bake condition of SU8? I think we have already discussed this. Okay.
See, 65 degrees per 1
Yeah.
minute.
65 degrees Celsius for 1 minute. Okay. Oh, sorry. It's not 1. 1 minute is according to the one given in the
Glass.
like class, but it is not giving us the thickness. Okay. Like I said, it will depend on the resist as well as thickness. If the thickness varies, this thing also varies. The soft bake, hard bake time, as well as the exposure dose also varies. Okay. When we are exposing, it is not that just we know that it is 365 nanometer we are using for photolithography. Fine, but this light also will have some intensity, and that intensity has to, like, if we have a photoresist of this thickness, the light, this wavelength has to reach till here, and it has to penetrate till the whole photoresist. This is the photoresist if we have. Okay, for that there is something defined as dose of the photoresist. Okay, so dose as well as soft bake time and hard bake time, these three depend on the time. I am not talking about the value. This is fine. This will depend for a specific suppose you are using SU8, that is 65 degrees Celsius, fine, but for how much time, that will depend on the thickness. Okay. So it is time dependent, but temperature is fixed. Okay, at this temperature for how much time? While using SU8 as resist of the lithography, hard bake is done at 95 degrees after PR development. Is it true or false?
False.
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 Why?
False.
Why
Because
is false?
it is done before PR development.
Before PR development. So it should be done before PR development. Fine. So the hole for inlet and outlet for the microfluidic chip is created on PDMS by soft lithography, photolithography, acupunch with fine needle or screen printing. Yes, any answers?
C, I thought so.
Ac- Acupunch with fine needles. And
Yes.
why cannot we do it with soft lithography since we are patterning with soft lithography, right?
Yes.
Yes. So why is it not done using that?
So we can also do soft
I'm not able to
lithography.
hear you. Your voice is very low.
So we can also do with soft lithography also.
But like, suppose you have a soft material, okay, and you keep it hanging like such a structure, okay, and this is a soft material. At the end, it is open, okay. So what will happen? This is a soft material, soft like gel kind of material, okay,
Yes.
and if you keep it like this, hanging, so what will happen to it?
It will drop down to the bottom.
It will drop, like it will just come down in a sense, right? So, though we are patterning it with soft lithography, but this problem will happen. Okay. So, in general, what is done is that such a structure is made, like a small wall is kept at the edges, and when at the end of the whole process, once it has dried and all, okay, we just punch it using acupunch, using a fine needle. Fine.
Yes.
The PDMS mold is attached to the patterned glass substrate to form microfluidic channel by heating oxygen plasma, nitrogen plasma, or argon plasma. Any answers for this?
Yes.
Yes, any answers? Anyone? The answer is oxygen plasma. Okay, but why cannot we go for a normal heating? Any thoughts on this? Yes, any answers for this?
Yes.
Your voice is very low. Like, cannot hear you.
Sir, I have no idea, sir.
Okay. Anyone else?
Sir, maybe increasing temperature will change the mold shape or something.
Yes. So if we go for, remember like when we were talking about CVD and thermal also like metal deposition and all at the beginning, we saw that wherever there are some materials which cannot sustain that much of heat, we go for plasma, like that much energy using plasma. So a similar thing is to be done here. Like if we heat it, the shape will deform and like some other shape will form. So to avoid that, we are going for plasma and specifically oxygen plasma because here the bonding happens by making the PDMS hydrophobic, not hydrophobic, sorry, hydrophilic, like OH negative forms, group like OH groups forms at the surface of the PDMS and they bond with the with by making the silicon oxide silicon bond. Very similar to the anodic bonding we saw earlier. Okay, so now let's come to the next question. The microfluidic chip for rapid bacterial antibiotic susceptibility testing discussed in class was made on a glass substrate, silicon substrate, plastic OHPC, silicon carbide substrate.
Sir, C, sir.
See, so why not the glass?
OHP sheet is very low cost when compared to the glass substrate.
Yes, and any other factor?
So lab equipment is not available for all the people that we are testing or doing.
Why cannot we go for a like glass substrate? Is glass costlier than OHPC?
No idea, sir.
Anything sir have told? Yes, any other?
Sir, glass is actually the insulator for thermal also. Once you fabricate it on both sides, maybe the temperature may not go to ID.
Hmm, yes, but in this case also like OHP also don't have that much of thermal resistance you can say. Okay, like it cannot go to very high temperatures as well as it is somewhat insulated only.
Sir, which one is correct, sir?
anything like Dr. Birendra you would like to add?
A glass substrate we have seen, but I'm trying to figure out why it is. Sir, discussed in detail actually, if I'm
Yeah.
not wrong.
Yes.
Photolithography also.
Yes. And like, what is the full form of OHP? Any idea?
OHP, no idea, sir.
Is it overhead projector sheet?
Yes. So one thing is, if it is in projector, so certainly it is, one thing is about transparency, like it is very transparent, right? Food grade, flexible, like it has not one but many advantages. We can say that it is flexible as well, unlike glass. Okay, so like it can easily set with our material, like the chip. We can go for flexible chip and these things. There are many more advantages also. Just check on like that thing, because this reason is very important. Like why OHPC? Like the same thing we can go on a silicon substrate also, because the microfabrication on silicon is like much better. Even we could have made this microfluidic chip, uh, like microfluidic path on the silicon substrate, but we are going for OHPC. Okay,
So screen printing is possible for OHP
yes,
sheet.
screen printing is also possible on this, much easily compared to glass substrate. Okay, so there are such advantages. Okay, so in vitro experiments, material is used to mimic the what in our body system: tissue, tumors, extracellular matrix, blood or media.
C, sir, extracellular matrix.
Extracellular matrix, that is in fact the fluid available around the cells. Okay, so that we can have the similar feel as if these cells were inside the cell or tissue were inside the body itself. Fine. What is the method used to make heater or ID pattern on plastic substrate? Soft lithography, photolithography, direct writing using UV laser, or screen printing? So the,
So plastic substrate in the sense of is OHP sheet.
yeah, OHPC,
Yes, so screen printing is
screen printing. So we have seen talked about lithography. We have like soft lithography. We have talked about photolithography. Even direct writing using laser is nothing but like e-beam, very similar to e-beam lithography, like where the beam used is laser and the patterning is done as per command from a software that will have the pattern. Okay, so there's we know. So what is the screen printing process? Any idea about this? What what is screen printing? If we talk about in normal sense, what it looks like. Just any idea?
maybe similar to the DTP publishing, desktop publishing. Where
Digital
they,
publishing. Yeah, in the sense.
like a printer, can directly print the
You
mask
are
or
going
something.
somewhat in right direction. Yes, please continue.
Maybe a laser printer, sir.
Okay.
Similarly, like a laser printer, but
Yeah. Have you seen those marriage cards like in India? Mostly when marriage cards are printed, have you seen how that printing is done?
that's true.
Like,
It's also
okay, like
a kind of
uh,
printing.
printing, but if you might have seen that earlier, like nowadays, it is very easy, very easy that people put in a Word document things and then things are printed, like newspapers are printed uh, normally. But if you take a newspaper, a bit older newspaper, say, like, I will say till 2000s also, I think this technique was very commonly being used. That if you see the letters, you will find that actually every letter is a matrix small, like if you have to print this, a small net kind of structure will be there. Okay? Have you observed this? Like, and even the cards, like marriage cards, and these are printed like that. So what is done is that let me take plain. Okay, sorry. Like suppose we have a sieve, like a net, very thin net. Okay, I am making big, but it will be a very thin, very small, uh, very small holes will be there. Okay, and on this, very similar to what we make mask. Okay, so another material is like a material, photosensitive material, sensitizer it is called. It will be pasted over it, spread over it. Okay, the whole thing will be spread. This is a light sensitive material. Then suppose we have to make the ID pattern. Okay, so on a plain sheet of paper, okay, not plain sheet, sorry, on a transparent paper, that is tracing paper. Okay, tracing paper. Okay, you print the structure that you want. Now, in what areas light will pass if we put it in light, this tracing paper?
Unprinted regions, I think.
Unprinted region. So this is put above this, okay, and it is uh, pasted properly and put in light for some time. Say like that depends on what kind of sensitizer you are using. Okay, and then it is brought back in dark. This tracing paper is removed. Now the area that is exposed to light, that means all the area except this pattern, that hardens, very similar to the lithography process. Okay, but this cannot be done at a very small scale. It will be at a larger scale. Okay, so this material that was coated had actually filled up all the holes. Okay, that is a thick material. So now when we remove this and wash it, the area that was under this mark, the printed mark, that will wash out. Okay, that will go away, that will wash out, and other area will remain covered. Now this is put over paper or wafer, whatever you want, and then ink, say gold particles mixed in a suitable resin or suitable oil, it is put over it and squeezed. So a thin layer of that thing will form below it on the paper or wafer or whatever we want. Okay, seeing from the far, it will look like a complete structure. But if you see it very closely, like below it will be a complete structure, but above it, you will see the mark of small sieve or small net kind of structure. Okay, this is the similar technique that was used for many decades in printing technology, in case of this newspaper printing and all. Nowadays, it has been replaced with digital printing, still marriage card and many things which have to be printed in bulk. And in fact, book printing are still at many places being done using screen printing. Okay, so a same technique is used to make these electrodes also. So it is much easier, and you don't have to do so many processes. You make one sieve with this pattern, and you can make as many sensor, like as many electrodes as you require. You just put the gold ink, squeeze it, done. Like, make it up, let it dry, it is done. So that is the screen printing. It is easier, cost effective. You don't have to go through so many processes. But yes, you cannot go for very smaller dimensions. That is why you might have seen that these were a bit bigger compared to microchips we are talking about. Like in normal cases, in one single wafer, 200, 300 chip can be made. But in this case, they were bigger. Okay, fine. Like, are you clear with screen printing?
No, sir. Thank you.
Yeah. Okay. So, how is a microfluidic chip for drug screening functionality different from a microfluidic chip for antibiotic susceptibility testing? What is the difference? Any anything like for both? We saw a similar kind of thing, right? Impedance is being checked and all. Yes. Any answers for this?
Maybe depends on, sir, channel, whether it is like for drug screening you are using an array,
Mhm.
and sometime in other devices we use only one channel. Maybe, I'm not sure.
Yeah. Any other difference? Anything that like one thing is channel. Okay. Any other thing that comes to mind? Yes, Arvindji, any inputs from your side?
The microfluidic chip for antibiotic susceptibility should be very cheap when compared to the drug screening function.
Cheap is there. Okay.
That is, it should be low in cost.
The chip. Okay.
Can be easily manufactured for many people.
Okay. Why? Because we want it to be tested for personal drug testing, right?
Yes, sir.
One thing is that. Any other difference between the chip itself, functionally? how it was functionally different. Like in both the cases, we have this no, like we are going to check the impedance, right? So how is it functionally different? One is like we want rapidly screen the drug. How is it performing? Okay, like is it working or not? Okay. Other is the case when we are going for this antibiotic susceptibility testing. How well, like at what point it is working, for what values it is working. Okay, so we want these things. So what is the difference between this? Yes,
So both are very similar.
both are very similar. Yes,
We are testing the impedance on both cases.
yeah. So what is the difference?
In first case, we are testing the impedance of the bacteria or sorry, cancer tissue. In the
Hmm,
second case, we are testing the bacteria,
hmm.
bacteria susceptibility. In the first case, we are testing the cancerous tissue. Is it a difference, sir?
Function, like what is the difference in how they function? In both the cases, we are checking the this impedance only. But is there any difference between the function?
Both the chips have inlet and outlets. We can send the stained blood,
Mhm.
test our drugs. Drugs which we can use more number of drugs to test in the cancerous tissue or something. In the second case, only in antibiotics, how it reduces the growth of the cancer bacteria growth. Also.
So is it a structure like in both the cases? Is there just some structural difference or not?
Yes, sir. So the structural differences will be there. So there is a large tube for flowing the what it is called media,
Mhm.
and the second is short tube. The cancerous tissues will be placed. Dynamic testing.
Yes.
So,
Fine. Okay. This is some essay type of question. Certainly, it will not directly come in the exam, right?
so
But you can just check like what is the difference, because both of them look very similar,
yes, sir.
right? Okay. Now the next is a heater is required in the microfluidic chip for rapid drug screening. Is it to keep the cell alive by giving 37 degrees Celsius to improve the sensitivity of ID sensing, to kill the cell by providing 37 degrees Celsius, or A and B? Yes.
To keep the cell alive, um, by giving 37 degrees. So
Yes, this is fine.
A is correct.
Yeah. B, the sensitivity. In fact, in all this, there is no sensitivity testing based on temperature, right? Otherwise, we could have gone for different temperatures and seen that for which point, like for which temperature actually it is best sensitive. Okay, we are directly going for 37 degrees Celsius. Why? Because we want that the cell remain at the in alive condition in the normal body condition, right? So certainly the second is not true. If it was done like, and it was found that yes, at 37 degrees Celsius actually the ID is giving the best sensing performance, then we could have said that, but that part has not been done anywhere, right? So second is not correct. Okay, certainly with temperature, ID sensing performance will differ for different temperature. It will be different. Some it might increase or decrease based on temperature. Fine. So it is one only. Fine. Any other questions or anything you are not able to get, you can ask.
So in the one of the graphs, it was shown normal impedance on the
Mhm. Normalized
y-axis,
impedance. Yes.
normalized impedance. Is it the normalized impedance should be in between 0 to 1? But here
Yes.
it was more than 1. How it is
It is
possible?
based on this some value. They are. It is based on taking a certain value. Okay. Let's say we have an impedance of 500 ohm. Okay. Okay.
Yes.
So we are saying that this is 1. Okay.
Yes.
So if it is decreasing, it will be say minus 0.7, 0.6 like that. But what if the impedance increases above it? So it is dividing by 500. Like
Yes.
suppose at the starting point you see in all these cases it is 1. Okay. So whatever the impedance value is at this point, we are taking it as the standard impedance or the base impedance. Okay. And we are dividing the whatever impedance come with this value. Okay. So sometimes you might see that though like thinking it should be straight only, like this should be the limit, right? But actually this is the center point, we can say. Okay. This is the base point. Sorry, not a draw straight. This is the base point. Okay.
Yes.
This is the normal value. If nothing was changing, it should have remained straight line at this point. Okay. So if in some cases actually the impedance is increasing beyond this point. Okay. But if you see, if no drug is applied, actually the impedance decreases because the number of bacteria is growing, the charge is increasing, the impedance will decrease. So the impedance is decreasing from the base value in all the cases, the normal cases, in both of these, right? It is going below. Certainly, it will not go up because we are not removing all the bacteria at once. Like suppose at the beginning there were 10, sorry, yeah, there were 10, there will never be less than that in normal growth condition. But if we are using some drug or all, there can be some condition in which they are gone. So if you see the graph and you find that if the drug, in this case you see this drug, even after 60 minutes, it is not reach, no point it is reaching above this baseline, normalized 1 line. Fine. Whereas in this case, for two concentrations are able to reach beyond this baseline. So what can we make from this? Like what difference can we understand from this? Any idea on this? Like in this case also we see that for two different conditions, like actually for the two highest Is it visible on your screen or should I zoom it?
No, sir. I can zoom from here.
Okay, fine. Like this, you see that for these two highest concentrations, actually the impedance goes above this baseline, the one value.
Yes.
Okay, so what we can make from this is that actually at this point, the number of alive bacteria is less than what was at the beginning. Suppose we started with 10 bacteria, here it is less than 10 bacteria because it is above the baseline. That means the impedance is even higher than what was at the beginning. So if we started with 10 bacteria, it is less than 10 bacteria that are alive here. So this is like it is the most effective one. Whereas if you see this one, though
Yes,
this
sir.
drug is killing them, but it is not that effective that it is able to reduce the numbers to very low, like even below the point where we started. Are you getting?
Yes, sir.
Okay. Similarly, in this case, we are seeing that now if we compare which one will be more effective if we see this A and this is E, right? Out of A and E, if we see which one is more effective, though both of them
That,
are above
no,
it, right?
yes,
Yes.
sir. Yes, sir.
So which one seems more effective?
Dopamycin 100 micrograms per ml. Is it, sir?
For
I
that,
think
we can we
is it
can
circuit
directly,
or square? Actually, I don't know. It is not
yeah, not
visible.
an issue. Like I am directly comparing both the graphs, right? This one and this one. So if you see, if I draw it properly, the line here, okay, and the line here, okay, the difference from this line to this, are you getting this arrow? This,
Yes,
and in this case, the difference. In case of E, the difference is larger compared to A. That means this has been able to reach at a higher impedance compared to A. That means the number of bacteria alive is lower in case of E compared to A.
yes,
Right? Higher the impedance, lower is the number of bacteria alive. Right?
yes,
So, like once you have got this, then if we superimpose above each other, like suppose we make it in different lines, different colors, okay, then we will be able to get which one is better, even though both of them are working, but they will have some difference. Some is more effective, like for the same thing, it, if we take one medicine, it will have different efficacy, another one different efficacy, though both of them will cure but with different rates. Okay, and sometimes it is not only the rate of the action, like we engineers only see this, engineers or chemists, we can say that we are more interested in how fast it is working, but along with that there are other parameters also which are taken care by health professionals, like they see what are the side effects and all those things that are latter part of the study. First we see, and that is why more than one drugs are tested, like two three probable drugs are given and then they do the further testing. Fine, got clear now what is this
yes,
normalized impedance and all. Okay.
yes, yes. It's clear.
Yes, anything else?
Okay, sir. Thank you, sir.
Okay. So that's all for today. See you all in the next class.